I'm Jaron Kelleher.
This is our senior design project that we made for our electrical engineering degree. Our team name was Cyber Systems, and this is our project called Skynet. Basically what it is some sort of, it's kind of a weapon that someone can use to more or less target enemies from somewhere that's safer. They basically just wear the helmet and they can, using head movement, control the camera, which is mounted. It's considered a turret. We have a laser on there to use as a weapon, and Sharon's going to talk a little bit about the motivation of the project.
Alright, so our motivation for this project was definitely the military. What we wanted to do was create a turret that would be wirelessly controlled by the user. So like I said, we talked about what it does. The ways to implement this would be, one of the most dangerous positions is a gunner on top of a Humvee. So rather than actually having a gunner sitting on top of the Humvee, open target, he could actually be inside the Humvee wearing this helmet right here. There could be a camera with a weapon mounted on top. He'd be able to see what the weapon is aimed at through these glasses right here, and through the firing mechanism, he could look wherever he wanted and then fire the weapon under the protection of the Humvee. Another application would be, say, a building that has hostiles in it. Put something like this on an RC car. Instead of having someone actually have to go in and attack the hostiles, you could send in the RC car for like a surveillance or anything like that, and look around wherever you want. If you see a hostile, fire the weapon, that whole thing. So now we're going to talk about actually how it works, and so the ways we made it work. Go ahead.
Okay, so basically this was, you can't tell, it was an old motorcycle helmet that we had sitting around, so we modified it. We have a client side and a host side PCB. The client side is inside the helmet right here, and the host side is in the helmet. The client side is inside this control box on the turret. In order to communicate between the two, we have XP modules that are just sending information back and forth, and the main two components of our project were head tracking and video overlay. The video overlay being performed as a GUI, or a heads-up display rather, on the glasses for the user to be able to target whatever they're trying to shoot. So Jaren's going to talk a little bit about the head tracking.
Alright, so the way the head tracking works is we've got two sensors on here, two MEMS sensors, gyro and accelerometer right here. So they send their signals to an MSP430, which converts it to a digital signal. We perform a Kalman filter on it to get the actual pitch and tilt that the helmet is at. This data is then sent wirelessly over the XP to the client side. The client side then updates the PWM signals that are controlling the servos, right? So if I tilt my head upwards, to 45 degrees, I'm going to calculate that angle, send 45 degrees over this way, and it will update the servos to move the camera up to a 45-degree position. Same thing with tilt. If I tilt my head to the left 45 degrees, the camera will actually turn to the left 45 degrees. There's also the weapon. The way the weapon is fired is by pressing this button right here, it makes one pin go high on the XP, and it's just a digital transmission to the other side, which then sets off this burning laser on top. So that's pretty much how the head tracking works. Mike will talk about the video overlay.
So the video overlay is performed using a parallax propeller chip. It's basically just taking the analog video feed that's coming in and coupling that through two MOSFET switches. And based on what we program on the output of the propeller, we can choose how much transparency there is basically on the overlay that we're putting on it. Because of that, there's only a grayscale image. It's anything between black and white. And that's just overlaid on top of the analog feed before it's sent to the goggles, and using that the user can use a crosshair to target or receive mission information and things like that. So we're going to go ahead and give a real live demo of this now. Okay, so Jaren has now put on the helmet. You can see he has his hand next to the button ready to fire. We've set up the turret right here in front of my doorway, and two balloons on the door so that we can pop those. And we also have an auxiliary feed coming out of the back of the helmet that's connected to our TV, so you can actually see what Jaren is looking at through the goggles right now. that right there is a feed that he's getting in front of him. We're going to go over the head movement real quick. If he turns his head, or to turn the turret left, he's going to tilt his head to the left. And similarly, if he tilts his head to the right, it will turn the turret to the right. Up and down movements are controlled by tilting the head up and down. So that turret right there is replicating the movement of his head, and he's targeting using the crosshair that is in the center of the screen. That is the laser that is being shot out of the turret.
Alright, so go ahead and shoot down the first one.
So that's the first balloon down. And now we're going to do this test again from a remote location. We're going to unplug the video feed from the back. And Jaren is going to go into a different room. He's going to be in the bedroom. And so this would be more like a real life situation where he is out of danger of the balloons. And he is going to now shoot down the second balloon. And that is it. So Jaren can now come back because all the enemy balloons have been destroyed.
Alright. I think that'll do.
And that's the end of our project. Hope you guys enjoyed.
Yeah, thanks for watching. Hopefully maybe this will motivate some other type of wireless controlled turret design in future projects. Some mods that we would like to make to this project would possibly be, rather than tilting your head to turn the camera left and right, I prefer, it'll actually follow the full motion of your head. That's one future mod we'd like to make. Another one would get more powerful lasers on there, so we can shoot from a longer distance.
So once we get those mods done, you can expect to see another video. We will post another video with the mods done. And until then,
thanks for watching.